Okay, so here is our second example for systems with varying mass. So we have a 6,090 kilogram space probe moving nose first toward Jupiter at 105 meters per second relative to the sun, fires its rocket engine, ejecting 80 kilograms of exhaust at a speed of 253 meters per second relative to the space probe. What is the final velocity of the probe? So our initial mass is 6,090 kilograms. And then our velocity of the space probe is 105 meters per second relative to the sun. So that's just going to be our actual velocity because the sun is like an outside observer, right? So initial velocity is 105 meters per second. And then it says it ejects 80 kilograms of exhaust. So what this is telling us is it's telling us what our final mass is. Because we're ejecting 80 kilograms, we're losing 80 kilograms of mass. So mass final is going to be 6,090 minus 80 kilograms, which is 6,010 kilograms. And then those exhaust gases are ejected at a speed of 253 meters per second. So relative velocity, because it says relative to the space probe, is 253 meters per second. And then it says, what is the final velocity of the probe? So V final equals question mark. So the equation that we need to use for this is final velocity minus initial velocity equals the relative velocity times the natural log of mass initial over mass final. So we're solving for final velocity here, so I'm just going to add initial velocity to both sides. So we get relative velocity times the natural log of mass initial over mass final plus initial velocity. And then plugging in numbers here, we get 253 meters per second times the natural log of 690 kilograms divided by 610 kilograms, plus the initial velocity, which was 105 meters per second. And so here, times natural log. We end up getting 108.3 meters per second for our answer.